Okay, the warm-up slides are going over some questions that we went over in section 1.1. You should be able to determine the population and the sample in a situation. You should be able to determine whether the numerical value is a parameter or a statistic in a situation. And you should be able to identify what type of statistics we're dealing with, inferential or descriptive. So in the first one, take a minute with your partner, see if you can figure these out. And we'll go over them in a moment. Okay, in the first one, the age of every 10th person who walks into Kohl's. Everyone who walks into Kohl's is the population they're looking at. The survey is just using the sample of every 10th person who goes in. A survey of 357 teachers in Stark County found that 82% of them had a master's degree. Well, we're really interested in all the teachers of Stark County, so that's the population. The sample is the 357 actually got surveyed. A numerical value that's a parameter is dealing with a population, and a statistic is dealing with a sample. So a recent survey of alumni of a major university indicates that the average salary of 10,000 of its 300,000 graduates was $125,000. Supposed to be a zero there. Well, we only surveyed 10,000 out of 300,000. So that's a sample. So it's going to be a sample statistic. In this next one, the average salary of all assembly line employees at a certain car manufacturer is $33,000. So that's going to be a population parameter because the entire assembly line set of employees was surveyed. Identify whether it's an inferential or descriptive statistic. Well, descriptive statistics is just telling you the numbers. What was counted? What was observed? The average age of students in the statistics class is 21. Well, that's it. They're just describing the average age. So that is going to be descriptive. From past figures, it's predicted that 39% of registered voters in California will vote in the June primary. The word predicted is giving you the clue there. They are using information to infer something, predict something. Okay? So today we are talking about data classification, how to distinguish between qualitative data and quantitative data. Those are the two main types of data, and what level of measurement that data set is giving you. Okay? So the difference between qualitative and quantitative basically is qualitative is names, smells, colors, things that be put into some sort of category. Okay. Generally, they're not numbers, but they can be. If they are numbers, they're numbers that are just labeling. So, for instance, license plate numbers is a qualitative type of data. You're just labeling with it. Okay. Quantitative data is generally numerical. It has to be numerical. It has to be numbers. Things like shoe size, scores, weights, all that kind of stuff. All right? So, if it's just attributes, labels, or non-numerical entries. But again, it could be numbers if they're labels. It's qualitative. Quantitative is numbers that are measurements or counting. Okay? Measurements or counting. So here's another slide that kind of gives you that also. So words, objects, pictures, observations, symbols, that's qualitative data. Numbers and statistics is quantitative data. Okay? The big thing is, can it be counted? So if you're looking at the numbers of license plates, that's not something you're going to, the number itself is not a thing you count. Okay? All right. So the table shows sports-related head injuries treated at a certain ER. So what part of this table is qualitative and what part is quantitative? Well, the sport is a category. So it's qualitative. It's a type of category. The head injuries, though, can be counted. So it is quantitative. All right? So if you're just putting it in a category, you're labeling it, and you would be qualitative. If you can count it, or measured of somehow, then it's qualitative or quantitative. All right, moving on. Different levels of measurement. You have 4 of them. It starts at nominal. If you can put it into a category, it's nominal. So for instance, if you are looking at types of shows televised by a specific network, you've got comedy, drama, reality, sports, etc. You are just putting them in a category. That's nominal level. Ordinal level, you can put them in a category. You can also put them in order. So if you're looking at Motion Picture Association of American rating descriptions, you've got general audience, rating G, PG, PG-13, R, NC-17. So those ratings can be put in order from the most basic to the more higher level bad words, that kind of thing. So you can rank them, okay, in order. So interval, you can put them in a category, you can put them in order. They can be subtracted. You can find a difference between the data entries. So for instance, if you're talking about temperatures, you can subtract temperatures. July was, on average 10 degrees warmer than June. So you can subtract those if you had a list of temperatures by month. But the 0 is arbitrary, and what it means by 0 being arbitrary is 0 doesn't indicate none in an interval list. 0 just indicates between negative and positive. Okay? So when 0 is arbitrary, meaning it doesn't equal none, so you can't have, if you have a 0 degree Fahrenheit temperature, that doesn't mean there was no temperature. It just means you were between the negative temperatures and the positive temperatures. So that's what it means by 0 being arbitrary. It doesn't mean none. Okay? Ratio is the final level. So all of the originals are still in there. But now we can divide. We can find a ratio. We can take July's temperature. Let's not do that one. Let's do precipitation. Because temperature is interval. Precipitation. When we talk about 0 precipitation, that means there was no precipitation. It did not rain, it did not snow, nothing happened. But we could divide, for instance, July's temperature or precipitation that was 7.27 by January's precipitation that was 2.35 and get a ratio and say it rained this much more times more in July than in January. Okay? So if you can divide them, it's ratio. If 0 is a true 0, meaning that means none, the weights of fish, the weights of, or the temperatures, I'm saying this backwards, the weights of fish or monthly precipitation, that's a true 0. It means none. That tells you it's in the ratio level. Okay? If it makes sense that you could divide them and say, for instance, there's twice as much here than there, that would be a ratio level. All right? So, nominal levels, qualitative only, categorized using names, labels, or qualities. No mathematical computations can be made. Ordinal level is qualitative or quantitative. The data can be arranged in order or ranked. The differences between data entries is not meaningful. It doesn't really make sense to subtract them. Okay? So let's look at these 2 examples. Top 5 U.S. occupations with the most job growth. Well, you can see in this first example, they rated them. The top job for job growth is personal care aides. The second top job is registered nurses, and so on. Movie genres, action, adventure, comedy, horror, those are just categories. So if you can rank them, it is going to be ordinal. If you can't rank them, it's nominal. Okay, and then ranking them is ordinal. Okay. All right, so interval level, again, quantitative data. It can be ordered. The differences between data is meaningful, and 0 represents a position on a scale, not representing none. It's just a position on the scale. Ratio level, similar to interval level. The 0 is really important here. 0 means none. Okay? The ratio of two values can be formed, and one value can be expressed as a multiple of another. So looking here, New York Yankees World Series victories by years. Yeah, I can subtract years. I can put them in order, but it makes no sense whatsoever to divide years. You can't have this year being twice as much as the other year. And if you're talking about year 0, that's between BC and AD, which means, by the church calendar before Christ, and I don't know the Latin meaning for after that, but that's how our calendar goes. Okay, the 0 does not mean none, it just means in between those two time periods. If you're looking at the American home run totals by team, I can rank those. I can list, least to greatest. I can put them in order. I can subtract them. Baltimore had 253. Boston had 208. So if I subtract that, I get 45. So Baltimore scored 45 more runs than Boston. I can divide them if I wanted. So if I take, for instance, Baltimore over, I don't know, let's say Kansas City, I could actually get a ratio and say that Baltimore got 1.72 times more runs than Kansas City did. So if it makes sense that you can divide those, then it would be ratio level. Okay? So you've got to be able to determine between the two. And then this is just kind of a little thing you can go through your head to determine. So can they be put in categories? Yeah. Can you arrange it in order? Yes or no. Can you subtract? Yes or no. And can you determine if a data value is a multiple of another? Can you divide them and it makes sense? Yes or no. Okay. On page 12 of your book, there's a nice little chart, kind of with the examples that we talked about. I'm going to double check that it's page 12 because I'm thinking now that maybe, oh yeah, page 12. Real nice chart that you can look at that'll help you if you're thinking through things when you're doing your math Excel. And we will see you for section 1-3 next.